Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2135, indicates an issue related to the throttle position, TP sensor, specifically a voltage correlation problem between sensor A and sensor B. In Honda vehicles like the Civic, from model years 2011 to 2015, the TP sensor is a critical component that monitors the position of the throttle valve. It sends this information to the Engine Control Module, ECM, to optimize engine performance and efficiency. The throttle body, where this sensor is mounted, is located between the intake air duct and the engine intake manifold. When the DTC P2135 is triggered, it is essential to examine the electrical connections and the physical condition of the throttle body and the sensor itself to prevent potential engine performance issues. The error described by DTC P2135 is due to incorrect voltage correlation between the A and B circuits of the throttle position sensor. The TP sensor is designed to report the position of the throttle valve to the ECM, and inconsistencies in this sensor data can trigger this fault code. The throttle body, where the sensor resides, regulates the amount of air entering the engine and is critical for maintaining optimal combustion and engine efficiency. The ECM, located within the engine compartment, processes data from various sensors, including the TP sensor, making it pivotal for engine management. This correlation issue can cause improperly leaned or rich air-fuel mixtures, potentially leading to diminished performance or higher emissions. Several possible causes can lead to the DTC P2135 being triggered. First, a faulty throttle position sensor itself is a common culprit. If the sensor's internal components are damaged, they will not relay correct voltage signals to the ECM. Secondly, wiring issues within the A and B circuits of the TP sensor could result in interrupted or incorrect signals being sent. Third, an outdated ECM software may not recognize new sensor inputs correctly, leading to a mismatch in expected and actual voltages. It's crucial to inspect all components involved in this circuit thoroughly to ensure that you address the root cause effectively. The symptoms resulting from DTC P2135 may include the illumination of the check engine light on the dashboard, indicating a fault that requires immediate attention. Drivers may also experience noticeable engine performance issues, such as hesitation or stalling during acceleration. These symptoms can compromise vehicle performance significantly, leading to poor acceleration response when pressing the gas pedal. Additionally, fluctuation in engine idle speeds may be observed, suggesting an inconsistent air-fuel mixture. Addressing this issue promptly is vital, as it can impact overall vehicle drivability and fuel efficiency. The first troubleshooting step involves methodically verifying the problem associated with DTC P2135. Begin by turning the ignition switch to the on-to position without starting the engine. This preparation is essential for initiating diagnostics. Secondly, utilize the Honda Diagnostic System, HDS, to clear the DTC. This step is crucial, as it allows the vehicle's computer to reset and prepare for a fresh diagnostic evaluation. Following this, conduct an electronic throttle control system test, ETCS test, through the HDS, which evaluates the functioning of the throttle control systems in real time. After performing these initial steps, check for any pending or confirmed DTCs again. If DTC P2135 is indicated, the failure can be replicated, leading you to the next steps in troubleshooting. In this step, it's time to assess the throttle body operation. First, you must turn the ignition switch to the lock 0 position, ensuring safety before working on the throttle system. Next, disconnect the intake air duct from the throttle body, which allows clearer access to observe the throttle valve. Afterward, turn the ignition switch back to on, 2, to activate the system and clear the DTC again. A visual inspection should confirm the throttle valve's movement. Genuinely, it should temporarily move to its fully closed position once the ignition is activated. If the throttle valve reacts appropriately, the issue might lie in the sensor itself, requiring a throttle body replacement. If not, the investigation will progress to the next troubleshooting step. At this stage, the objective shifts to determining the potential source of the issue, which may involve the engine control module, ECM, or related components. Start by turning the ignition switch to lock 0 and prepare to jump the SCS line using the HDS, which allows for advanced diagnostics. The ECM connector, identified as C49P, needs to be disconnected to access the internal circuits. Next, continuity must be checked between specific test points within the connector. TH1, which is red, should connect to point 30, while TH2, pearl, connects to point 31. Continuity implies that the wiring is intact and functioning as intended, leading you to move forward. If not, the software in the ECM may require an update, or the ECM may need replacing. Now it's essential to validate the integrity of the wiring responsible for the throttle position signals. Begin by disconnecting the throttle body 6P connector, which separates the throttle component from the ECM's circuitry. Check for continuity between the test points 1 and 2, ensuring that TH1 and TH2 are not shorted together inappropriately. Like in the previous steps, an assessment is conducted in the condition where ignition is locked and both ECM and throttle body connectors are disconnected. If continuity exists, repairs should focus on fixing any shorts between the TH1 and TH2 wiring. If the wires are intact, it necessitates the replacement of the throttle body and subsequently requires verification of repairs to confirm that the problem is resolved. Completing the repair verification process is crucial to ensuring that any previous faults are indeed resolved. Start by turning the ignition switch back to the lock position, followed by reconnecting all connectors involved in the troubleshooting steps, including those at the throttle body and ECM. Once everything is securely connected, turn the ignition switch to on, 2, once again. A reset of the ECM is vital. It recalibrates the system and prepares it for normal operation. Finally, using the HDS, check for any pending or confirmed DTCs. If DTC P2135 is still indicated, further examination of connections and possibly updating the ECM software becomes necessary. If there are no DTCs present, troubleshooting can be declared complete. Preventive maintenance is essential to avoid future occurrences of the DTC P2135. Regularly inspecting the throttle body helps to maintain optimal airflow and mechanical operation, preventing the sensor from misreading throttle positions. Additionally, keeping up to date with ECM software updates from Honda can ensure the vehicle operates effectively with the latest parameters and maps provided by the manufacturer. It's also crucial to ensure electrical connections are clean and secure, as corrosion and loose fittings can lead to signal interruptions, triggering fault codes. Proactive checks can greatly enhance the vehicle's long-term reliability and performance, thus ensuring a smoother driving experience. In conclusion, troubleshooting DTC P2135 involves a systematic approach to identify and rectify the correlation issues between the throttle position sensor circuits. Starting with validating the DTC using the HDS sets the foundation for subsequent diagnostics. A thorough check of the throttle body and its electrical connections is vital in verifying the component's operation. If faults persist after all troubleshooting steps, considering ECM updates or replacements could be necessary. Adopting a culture of continual preventive maintenance is invaluable for ensuring that underlying issues do not recur, maintaining both safety and performance standards in your Honda Civic. Please like and subscribe to the channel. See you next time.